Here in part 2, it's all about lab configuration demonstration. We're going to demonstrate how to enable cookie persistence and encrypt cookie information using F5 BIG IP device. And for those who are new to this channel, welcome. I am your host, name is Dean Armada, and I am your cloud and data center rockstar. On this channel, we talk about tech careers and certifications, trivia and tutorials in cybersecurity, trivia and tutorials in cloud and data center, and my journey as an IT instructor. So feel free to check out the rest of the channel and consider subscribing. I'm here in our F5 BIG IP configuration utility, and I'm about to log in. So I'm gonna use admin and I will enter my password. And as you can see, we are already logged in. Now, we're gonna verify if there are configuration objects created. Under pool list, there is no pool yet. How about virtual servers? There are no virtual servers yet configured. And this is what we're gonna do. We're gonna create a new virtual server. We're gonna name it http_vs, and I'm gonna assign an IP address 10.10.1.100 with a service port 80. Now, under default pool, there are no pools yet, so we can't select anything. But don't worry, there is another way. Okay, without going to the pool list, I can create a new pool on the fly. All I need to do is click this plus sign, and this will take me to the new pool list configuration page. I am gonna create a new pool now with the name of http_pool. We don't need to add monitors, but we are required to add 3 pool members. So I'm gonna add the first pool member, 172.16.20.1, listening on port 80. I'm gonna click add. And then I will change the fourth octet to 2, click add. Okay, for another pool, fourth octet is .3, click add. And there you go. We now have 3 pool members in our pool. Oh, it's not yet created. I need to click finish. There. We have now a new pool, and this is automatically associated under the default pool of this virtual server. Okay, and the virtual server is not yet created. Let's just verify. So the name is correct, the destination IP address is correct, and the service port. And I will go down and hit finish. There you go. We just created our new virtual servers. Now let's test. I'm here in our Windows client. I already opened a Mozilla Firefox, and under here in the address bar, 10.10.1.100. This is the IP address of our virtual server. And a few minutes ago, it wasn't yet available. So as you can see, the connection has timed out message. Now what I'm gonna do is hit refresh. And as you can see, okay, the page is now available. It's now successfully connecting to our virtual server with an IP address of 10.10.1.100. And look at the page. As you can see, it is selecting server 1, okay, as the main pool member, but it's also distributing HTTP requests or our HTTP traffic to other pool members, such as pool member 3. How about 2? Well, it's not yet here, but if I hit refresh, as you can see, the traffic is distributed because you see some of the images are 2 and 3. Okay, still connected to server 1, but if I hit refresh multiple times, it will now change to server 2. Okay, and as you can see, images are distributing again to other pool members. If I hit refresh again, as you can see, load balancing is working properly. Now, what we're going to do is we're going to enable persistence. Okay, this allows us to skip the load balancing because we want to maintain connection to a single server. So we'll go back to our virtual server configuration, and I'm going to click this virtual server. And under resources page, this is where we will enable cookie persistence. Okay, and as you can see, by default, it's selected none. I will select the default cookie persistence, which is named cookie. I'm gonna click update. Oh, what is this? Why are we getting an error? Because cookie is a feature that is available only through web-based technologies. And as you can see, it is requiring us to enable HTTP profile. This HTTP profile allows us to understand the behavior of HTTP traffic. And this is a requirement for us to use cookie persistence. And I'm gonna click update. There you go. So we now have an HTTP profile enabled. I will go back to the resources page, and from here I will select again our cookie persistence. I'm gonna click update. There you go. Cookie persistence is now activated. Now let's go back to our Windows client. Back here in our Windows client, and as you can see, this is our previous page where it connected to server 3, and the images are distributed to other pool members. Now I'm gonna verify if our cookie persistence is gonna work. So I need to refresh the page, and as you can see, it's now connected to server 1. Look at the images. It didn't distribute to other pool members. It all maintains connection to one server, which is server 1. Now to verify this, I will hit the refresh button multiple times, and as you can see, it doesn't go anywhere. It's always connecting to server 1. And this is the main goal of our persistence. Now, to verify if this is really a cookie persistence, we can verify using the inspect option in our Mozilla Firefox. So right click on the page and select inspect. Now, this is the default view, the inspector, and this shows us the HTML codes. This is not where we're going to verify the cookie. We need to click storage, and from cookies, as you can see, there is our destination IP address, which is 10.10.1.100. And look at this. This is the cookie information. The name of the cookie is Big IP server, and the name of our pool, which is HTTP_pool. Okay, this is the default, not so secured because we are showing the name of our pool. And look at the value. The value, it looks like it is secured, but no, it is not secured at all because this can be easily decoded. Okay, so this is Mozilla Firefox. We can also test and verify to a different browser. So I'm gonna minimize this and I'm gonna open Google Chrome. Okay, I will point to the same destination IP address 10.10.1.100, and I'm gonna hit refresh. As you can see, it is connected to server 2. Now this has been cached. That's the reason why you are seeing images of 3 and 1. But if I click source IP address, this is consistently connects to server 2, even if I hit refresh multiple times. So as you can see, it is persisting to the second server or the pool member. Now, I mentioned that we can decode this information easily. From a Google Chrome, it is actually easier because there is an available extension. Okay, we call this F5 cookie decoder, and you can easily search this in google.com. So as you can see, I just searched F5 cookie decoder, and look at what we have here. Big IP cookie decoder. I'm gonna click it, and there you go. It says Big IP cookie decoder, and there's an overview here. F5 Big IP load balancer uses an encoded cookie to maintain stateful connection from client to server. So this is what's happening. This is what we're using, but we can decode this. Okay, we can verify the value of the cookie, the pool and the pool members. So how can we do this? All we need to do is add to Chrome. Okay, we're gonna add this extension to our Google Chrome web browser. And as you can see, we have now a new extension here. Okay, this is the Big IP cookie decoder. Now let's go back to the first tab and click this Big IP cookie decoder. Gonna click it, and there you go. So this is the name of the cookie. This is also the same name we had in the other browser. Take note, these two cookies are different, okay? Because this cookie, as you can see, we just decoded. The node or the pool member has an IP address of 172.16.20.2 listening on port 80. As you can see, we just decoded the value of our cookie, okay, which is the pool member, IP address plus the port. Now, take note, this cookie, okay, this cookie right here, okay, it has a different value, or I can click this. I can click this icon, and then if I click cookies, you will see the cookie value here, okay, and under Google Chrome, the cookie name or the cookie content starts with 386. Okay, this is a different value from our Mozilla Firefox, because in our Mozilla Firefox, the value starts with 1809 and it's connecting to server 1. In our Google Chrome, it is connecting to server 2. Now, let's encrypt the cookie. So first thing that we're gonna do is we're gonna create a custom HTTP profile. So under virtual servers, not under virtual servers, under local traffic, profiles, and under service, we have HTTP. As you can see, we have default profiles. We're gonna create a customized one. And what we're gonna do is we're gonna name it first. I'm gonna name it Encrypt Cookie, okay? And we need to customize these attributes, okay? Encrypt cookie name and the cookie encryption passphrase. And to do that, we need to click this tick box, okay? Not this one and this one. There you go. So under encrypt cookies, this is the cookie name that we're gonna use, okay? So basically, we are renaming the cookie name because by default, we were using big IP server and the pool name. That is very unsecured. And we're gonna use a new name, okay? We'll name it Encrypted plus the passphrase. Now, the passphrase can be anything, but we're gonna make it simple. I just use ABC123. And there you go. We can leave everything else. I'm gonna click finish. There we go. We have now a new HTTP profile. Next thing we're gonna do is we're gonna create a custom cookie persistence. Under profile persistence, I'm gonna create a new persistence. I'm gonna name this Cookie Monster. And then I'm gonna select persistent type cookie. And nothing much to edit, only the cookie name. Now the cookie name must match the cookie or the cookie name that we created or we specified when we created our HTTP profile. This is the name that this persistent profile or this cookie persistence profile will be using. And we know that this cookie name will be encrypted later as we use it. I'm gonna click finish now, okay? We just need to make sure this is the name, encrypted, because if the name is not matching the name of what we specified in the HTTP profile, the encryption will not be successful. I'm gonna click finished, okay? And there you go. We have now two new application objects. We still need to associate these two new application objects that we created into our virtual server. And as you can see, we are still using the default HTTP profile. Now we need to use the new one, the one we created. Name is Encrypted or Encrypt Cookie. I'm gonna click update. And under resources, we need to change this to the new persistence. Okay, I had a typo. It's supposed to be Cookie Monster only. Accidentally, I added R. Cookie R Monster. Anyway, I'm gonna click update. There you go. Now, what we're gonna do is we will go back to our Windows client and test. Back here in our Windows client. And what we're gonna do first is I will delete this. I'm gonna delete all cookie in our browser. And I'm gonna hit refresh. Okay. I'm gonna click cookies. And there you go. We have now a new cookie. The name is Encrypted. And look at the value. It is now a value that cannot be decrypted. Now, to verify this further, we need to go to the other web browser. Okay, this is the Google Chrome. And I'm gonna hit refresh. No, before I do that, let me delete this cookie. Okay, so this is the old cookie. I'm gonna remove this, okay, because we just want to verify the new cookie named Encrypted. I'm gonna hit refresh, and as you can see, change the node address to 20.1, okay, because again, this is a new cookie persistence. And even if I hit refresh multiple times, it will maintain to that specific pool member or servers, okay, 172.16.20.1. Now, if I click this and we verify the cookie name, it is now the new cookie Encrypted, okay? And the content, again, is not the same format of the encoded cookie. It's now encrypted. Now, to really test if this is encrypted, we need to use the Big IP decoder, okay? So I'm gonna click this extension, okay? And I'm gonna select the Big IP cookie decoder. And this is the cookie name, the new cookie name we have. I'm gonna click this, and look, your node is NA, whatever, okay? This just means that this value cannot be decrypted. And our cookie encryption is working properly. Just a little trivia before we go. Have you ever wondered why they call it Internet or HTTP cookies? We now know that cookie is a small piece of data that server sends to our web browser. And this enables tracking and analyzing user behavior. The idea of leaving a trail so you can easily go back came from the fairy tale Hansel and Gretel, where the siblings leave physical bread or cookie crumbs to find their way back home.